Okay, hello everyone. Thanks for the introduction. I will do my best to not keep you from lunch any longer than necessary. So, welcome to our presentation on security automation for GraphQL. As he said, I'm Anthony Trummer, the consulting director at Doyensec. I was formerly the director of security architecture and engineering at Tinder in the Match Group. I also worked at LinkedIn in AppSec and incident response. I've spoken at various conferences, including DEF CON, Black Hat, B-Sides, the OWASP AppSec conferences, etc. I've also specialized in mobile application security at times, including creating Quark. It's an Android static code analysis and exploitation framework. And some of my contributions have been recognized in the Android security team's security acknowledgements. So, in case you're not familiar with Doyensec, we're a boutique application security consultancy. You'll find us sitting at the table in the far right down the hall here. We have contributed in many ways to the GraphQL security community. You can see the results of some of our security audits on Apollo's website. And we would invite you to check out our open source tool InQL, which Andrew presented a little bit about earlier today. It's designed to help dynamically test the security of GraphQL deployments, and we're always looking for contributors as well. Also, we are hosting the security office hours on site here in that vendor area down the hall there. So if you want to stop by and get some free security advice from us, our team is there to help. In this presentation, we'll cover various aspects of automation for GraphQL, with the key takeaways being the knowledge of the what, how, and when as they relate to the tools and processes that you can use in your development efforts. So why do we want to automate? Borrowing from Colin Green's blog, it's pretty simple. We want to shift left, right? We want everything, and I will make use of the laser printer here now. We want everything that isn't prevented to be found automatically. Obviously, all the rest of these just introduce more risk, more cost, and more work for us. So, before we can automate security processes, we first need to know what types of issues we're looking for. Some common sources for finding issues would be, books, how-to guides and documentation, blog posts from experienced security researchers, etc. One underutilized resource that I like to use and I find useful are the public disclosures from bug bounty programs. Why would you want to wait for some bug that's already been discovered to be found in your environment, only for you then have to deal with the fallout as well, and also have to pay a bug bounty if you have a bug bounty program. Additionally, these are things that were discovered in the wild, as we say, so it implies that they're much more likely to have been duplicated in your environments than some theoretical blog post vulnerability or something. So once we do know what we want to look for, we can identify the tools that detect these vulnerabilities. If the tools don't exist, we look for how we can create something ourselves. Maybe it's a simple shell script that greps through the code, or possibly it's repurposing a non-security tool like curl or a proxy or something. There we go. All right. These days, robust modern application security programs look to prevent security issues by looking at their code through three lenses. Firstly, via static analysis, in other words, looking at the code on the disk. This usually entails tools that search the code for common anti-patterns, untrusted inputs which are not being properly sanitized, or otherwise being overly trusted. This includes using tools like semgrep, Veracode, which is a paid tool, and find bugs, etc., those types of things. Secondly, these days there's a sharper focus on what they call software composition analysis or supply chain issues. In fact, there are several new tools or more modern tools that they're capable of understanding your dependencies and the build processes, so they will report vulnerabilities in your projects due to the libraries that you've included, the third-party libraries that you've included, and to some extent they're even capable to find vulnerable dependencies within dependencies or sub-dependencies, right? These include tools like SNYK, S-N-Y-K, SemGrep Supply Chain, and GitHub's got a feature called Dependabot that also does the same thing. We actually have some information on our blog about some research we did in that area too about their quality. Anyway, lastly, there's dynamic testing. This helps find bugs that are more readily identified in running code or are byproducts of the actual environment in which it's deployed, right? So it might be a configuration issues or some issue with the environment itself. One tool that can help in this area is our NQL tool, but we'll talk about some others today. Now, I'll grab the pointer here. Let's see, did I advance? Okay. So looking at a few popular open source or free tools, some of which are general use and others that are GraphQL specific, we start with some static application security testing or SAST applications. First of all, SemGrep, this bottom left here. This tool performs basic source to sink mapping, identification of common configuration errors, and optionally with proper licensing, it can do that identification of vulnerabilities within dependencies. Also, the security community has contributed several GraphQL specific detection rules to this tool, to the free publicly available rule sets. So you can easily leverage the crowd to help find some of the issues in your environment. Next, we have TruffleHog. Now this isn't GraphQL specific, but it's something you see in basically any software repository. The problems that it finds, that is that it specifically searches for secrets, passwords, cloud provider credentials, etc. in the source code, right? Basically in order to prevent them from leaking into the world somewhere. This tool is context aware, so it does recognize some standard credential formats and keywords, and saving you the time of having to keep abreast of those yourself, right? Now both of these tools would normally be run against source code, these bottom two, would be run against source code files or the repos directly, so you just need to give them access to whatever code you want scanned. No like elaborate setup needed, right? In theory, you could run them against just diffs of new code, but the best results are typically from scanning the entire code base, although obviously that's a trade-off on time, right? The second group of tools are the dynamic analysis or DAST applications. These are intended for testing a running API instance, whether that's in dev, test, or prod is up to you. First we have GraphQL map. Did this give up on me? Of course the pointer gave up on me. Anyway, yep, all right. So the middle GraphQL map, it facilitates security testing by mapping the APIs and providing a client, which enables field fuzzing, batching of requests, and testing for things like SQL and NoSQL injection vulnerabilities. Next, we have GraphQL crawler. I don't know if you can see the definition there, but it's supposed to look like a little spider or a bug on the right-hand side. So the green one. Anyway, this maps the API via introspection with a JSON file you provide, or it can actually brute force the schema as well. Then it identifies availability of any sensitive queries, checks whether mutations are enabled, and will attempt to find queries which don't require authentication. You hear a lot about authentication and authorization here, right? So anyway, I won't dive into that, but these are common issues that you'll see that often result in real-world data breaches. And lastly, we have GraphQL, the upper left, as you look at it. Yeah. This is another tool that facilitates brute forcing and fuzzing. It can also use several techniques to avoid API defensive measures, including things like query cost analysis. You'll hear some people talk about hardening and doing these steps. Well, the tools are always trying to catch up or stay one step ahead of the defenses, right? One way it defeats some of these protections is through batching a single query or mutation into several alias operations, right? When you talk about hardening, these are some of the things you try to protect against, right? Additionally, it can be used for password and multi-factor OTP brute forcing, user enumeration, and finding things like authorization issues because it allows you to iterate over large numbers of identifiers. Click again. It's been said that fixing security bugs pre-release is up to 10 times less expensive than once they've made it to production. Regardless of what the actual number is, it's pretty clear that it's cheaper, right? Therefore, we're well served to run as many tests as possible as early in the process as possible. Typically, the earliest testing is done via pre or post commit hooks, or maybe even an IDE integration. Now, as a developer, you may not want that feedback right there in your IDE, but it is the ideal time. So if you do it at this point, at least you'll know you won't have your deployment blocked at a later phase, for example, by a Jenkins job or something later in the CI/CD process. As you know, having to stop what you're doing, circle back, familiarize yourself with some code that you've completely forgotten about, fix it, re-release it, horribly inefficient process, right? So it's much easier to just stem the tide right there, right? Regardless of what happens on the developer's desktop, though, static analysis tools are typically run against repositories on a periodic basis as well. This includes like semgrep and trufflehog, like I talked about, because you do this partly to avoid the risk of someone disabling a check at the desktop and maybe it never gets performed, right? Or if you're not confident to block the release process, or maybe you have someone, typically a security team, right, who's dealing with the output from the tools, out of band. So you need to deliver the results to them rather than just the person who's running the scan. So now, even if you've done a lot of testing pre-release, you're always going to still want to run some set of dynamic tests against the production instance. Firstly, because there will always be a chance that the environment itself creates some sort of vulnerability. For example, it can be a config difference between environments. Another reason would be to monitor for regressions, where previously resolved security issue resurfaces. This happens very frequently with security fixes, especially when QA test processes don't look for security bugs. So, taking a look at some tools in action, we'll jump to the video in just a second. I don't know how thrilling it'll be, but it is what it is. Here we have an example of a screenshot of running semgrep against something called the damned vulnerable GraphQL application. If you're not familiar with it, it's basically a purposely vulnerable sample app, right? It lets you teach yourself about common vulnerabilities in GraphQL, and you can play around with it to familiarize yourself with the kind of things that you'd expect to see in a broken application. It's relatively small, so semgrep takes like just less than a minute to scan it. Now we're using something, if you can see there, it's the -- config auto parameter we're passing in. And what this does is basically tells semgrep, hey, why don't you decide what you think is best to scan this repo with. You can see it detects sort of like how CLOC does. It detects the languages in use in the repository. Do we want to switch to the video? So, any luck? So everybody likes watching tools run for some reason. So you can see it's basically just identifying what's in the repo. It scanned 127 files with 1,600 rules, right? And in about 20 seconds here, it'll come back with its results. I'll tell you the first one, just for the sake of time, I'll tell you the first one's going to be a credential that was left in the repository, so it finds some hard-coded secret. I don't remember exactly what the context of the secret is, but it's irrelevant. And then you're going to see a lot of other results. And to summarize, I don't remember what I'm scrolling through here, so you just have to forgive me. I don't tempt demo gods by doing live demos, sorry. But the next one I think I'll highlight here is going to be the set of broken regexes that it finds, which would produce the ability to create a denial of service attack. So it just gives you a flavor of the sorts of things it can find. And like I said, there are community rules that you can contribute to or borrow from as well to kind of leverage the crowd. And another thing to highlight with a tool like this is that it's relatively easy to write rules for it. So if you come across a rule that's a finding in your environment and you want to catch it in the future, it's very easy to write a rule for it and contribute it back to the community or keep it internally if you're greedy, right? So that you can improve your process over time. It's very accessible. And next, I'll just quickly show GraphQL in action. So not much to see here. It's just a Python script and some parameters being passed in. One is a query that's just saved to a file, and the other is a word list, basically usernames and passwords that we've already have. There are scores of these you can download from the internet. There's common usernames and passwords. Anyway, it's making repeated queries, trying to find a valid set of credentials, and eventually you'll see at the end here, one of the long string, right? This is a successful attack. It matched up some username and password. But these are the kind of things that you might want to try to do in your environment to, find potential issues. Right, so I won't spend any more time on that. You want to switch back to the slides? Okay. So regardless of which software tools you deploy, it's important that they are used properly to actually prevent bugs from shipping and detect any that might slip through after the fact. Like what you're testing in prod, right, once it's deployed. An effective program requires much more than just setting up tools and getting results. For starters, getting and maintaining organizational buy-in is critical, right? And it's no easy task. For example, are the development teams going to be receptive to being blocked, or are you going to handle the findings asynchronously or out of band, right? If security is going to block, under what conditions does it make sense to do so? Typically, you're going to look at some combination of the severity, exploitability, and urgency to determine whether or not a vulnerability or a piece of code can ship as is, right, with a given vulnerability. Invariably, this leads to disagreements in whether or not something should be a blocker to a release or not. Maybe you're going to consider it a won't fix or something that will get fixed but at a later date, or something you're not even going to look for in the future, right? But either way, you have to decide who's empowered to declare that is a pass or a fail, right? And whether it can deploy or not. So even if you do get buy-in, the quickest way to lose it is with noisy tools, right? Especially if they're producing a lot of false positives. So it's important to strike a good balance. Usually you want, high fidelity tools, things that are returning very strong results. Better to have fewer results that are trustworthy than a bunch of results that you have to go through and validate. So if you end up blocking incorrectly too often, you're going to spend all of your time manually vetting the bugs, and you'll end up negating any of the benefits you get from the automation. Another issue that arises is what to do with security technical debt. Nobody wants to have their builds blocked by some bug that was written 2 years ago by somebody else. So ideally, you'd clear your entire security backlog prior to going all in automation, but that doesn't always work out. So a more common compromise would be to simply catalog all of the known existing vulnerabilities and then not block on any of those. Doing this, however, requires some sort of orchestration software and the associated processes that go with that. So once you have begun creating results, right, you'll start to get a good idea of the types of legitimate issues that keep coming up. You might find teams or individuals that require additional training, or you might find organization-wide issues which can be addressed by implementing something like a safe by default library. Either way, it can be extremely beneficial to take these real-world cases and turn them into a useful training exercises or some sort of like a improvement process, right? To help your experienced developers and your new hires. And what this does is it has a multiplicative effect and helps you stem the tide of these like recurring common issues. Let's see. So amongst the multiple questions that you're going to have to answer, skip forward here. Sorry, I'm behind on the slides. There we go. Amongst the multiple questions that you need to answer when implementing automation are how will you deal with the results of the tools? Are you going to repeatedly scan the same code? What about multiple reports for the same vulnerability in different places but originating from a common cause? What about recurring reports of the same exact issue but from different tools or different runs of the same tool? What about issues you want to ignore or scans that take too long, etc.? Buggy scans, things like that. For the issues of scanning the same code repeatedly, depending on the tools that you implement, you could potentially have a tool that takes hashes of files or lines of code, storing them and then skipping them if they are encountered again in the future. Many tools actually do this behind the scenes. I think like antivirus, backup software, things like that will typically do this just to speed up their work. But you do really have to think it through because changes in one piece of code can affect the security of another piece of code even though it was previously deemed to be safe. Ideally, you'll be creating a feedback loop, as I said before, to incorporate these tool results into an ongoing improvement process. This could include identifying training needs and the need for additional tools or further configuration of the tools that you have implemented. It's not uncommon to find even well-configured tools that may not complete their jobs in a timely fashion or just aren't useful in a time-sensitive release process. So what do you do with scans that take too long? You may reduce the scope of what they're scanning, reduce the number of things to check for, or run some scans in blocking mode and some in non-blocking mode, right? Each of these will have downsides and upsides, and you can create another option is you can create background queues that report vulnerabilities even after the build is already deployed in some sort of like a fast follow process. So eventually you'll end up with a situation where you have numerous tools all reporting with different formats, different issues being looked for, and eventually, and each with their own quirks. In the past, this has led me to create an orchestration tool. Architecturally, this tool can be kicked off with a simple script whose behavior is modified through the use of various parameters. Taken to the extreme, you can get a parameter that represents every repo and every build step so that you have like very tight control over exactly how you test each specific thing. But either way, by using this parameter model, you get this ubiquitous run X script that you can just put everywhere and you don't have to update clients in the event you want to change some of the back-end tools. Effectively, what you do, obviously you build in the logic in the back end to hide the results and quirks from the requester. Some tool starts getting noisy, you just stop returning results and return a pass, for example. You can turn it off effectively, right? The more you can also add parameters to new tools that didn't exist, or for new tests that didn't exist in the old ones without breaking, it provides backwards compatibility. The other ones will still run. Then you can determine, what to report, what to hide, how soon to return a pass fail. If you're an API designer, you've probably dealt with these sort of patterns before, right? I kind of highlight some of the possible parameters you might pass in, like you're going to do SAS in blocking mode or non-blocking mode. You're going to do software composition analysis. You're going to do DAS, and then the parameters you'd have to pass in necessarily just so it knows what to do. And then just some hypothetical things about like, only test for this severity, who to send the report to, do I skip the existing stuff, et cetera. Some credential files maybe you need to log into your instance or something, those sorts of things. So when you put it all together, you can create generalized groups to summarize which tools make the most sense at different points in the software lifecycle. The last column is just kind of reinforcing that the technology doesn't live in a vacuum, so there's a necessary maintenance and tuning component. But you can kind of see we've highlighted, you're going to run SAS and SCA applications at the IDE or early on in the process, and then stepping through the kind of the build process. It may not map exactly how yours works, but you get the general idea. So to recap, the process of implementing automation requires a lot more than running a few tools. We first need to decide what findings we care about, and then which tools can help find them. Next, we want to figure out the best integration points and timing. all while avoiding a mutiny by our development teams. Our prize, if everything goes smoothly, we're lucky, we end up with a mountain of vulnerabilities to manage and remediate. So happy hunting. If you'd like some help with any of your application security challenges, including GraphQL, obviously feel free to contact us. Here's a QR code that you can use to supply any feedback that you have on the presentation. And if you'd like to contact us about this presentation or follow us for our latest security research, we're on X, Mastodon, and we have the booth where I'll be at after this, at the end of the hall to the right. Thanks for coming.